Yeah. Hi, everybody. So I'm Ernesto Boado. I'm from BGD Labs, but also from Aave. Like previously, I was the CTO at Aave. Well, BGD Labs, as a bit of introduction, because I guess like some of you are not familiar, we are contributing like to the Aave protocol, and well, part of this contribution is that we are doing an upgrade of the Aave governance system. So yeah, today I'm gonna present like how this new V3 of the Aave governance already, how it works, and well how it changes like the governance process like into a protocol like Aave. So yeah, to start with. I think maybe some of you are not so familiar how the current V2 of the Aave governance works. Some of you, maybe you are. But Aave governance V2 is similar to other DeFi protocols, like other governance controlling DeFi protocols. Is a fully on-chain system of smart contracts on where like holders of the voting asset, which in this case is the Aave token, and different flavors of this Aave token, like the SDK Aave. Well, they vote, they emit the vote by doing a transaction on chain, and once a proposal passes certain vote requirements, like basically a count of yes votes against no votes, if it crosses these requirements, like some executable code, which is what we call the proposal payload, executes whatever like is the content of this action. So it can be like a new listing on the Aave protocol. It can be a change of parameters. It can be basically anything related with doing changes in Aave. So yeah, this system lives completely on Ethereum, because as you know, like Aave is multi-chain protocol, but it started on Ethereum, and the Aave token majorly lives on the Ethereum network. So that is the reason of why like the Aave governance lives in Ethereum. Apart from Ethereum, that is where voting happens and creation of proposals and all type of validations. The current system also, well, we need somehow to change parameters and to do any other kind of change like on other networks. So to achieve that, we also have like a cross-chain governance system that we call, which is well, basically whenever like a proposal is targeting, let's say, like Polygon, so a message is sent via canonical bridges at the moment and arrives to the Aave instance on the Polygon side, and thus whatever change is required there. This kind of covers almost all the needs of a protocol like Aave, of even more an ecosystem like Aave, but is not without some flaws, like, or some point of improvement. And the most clear one is that is voting on Ethereum and doing all this kind of procedure in a network like Ethereum is pretty expensive. Because at the end of the day, like you, as an Aave holder, like emitting a vote can cost in the order of maybe $5, depending on gas. In moments where gas was really high on Ethereum, it was quite prohibitive, especially in, well, the Aave. The set of Aave holders is quite granular, so there is like small holders with a small number of tokens. So as you can imagine, like if you have like 10 Aave tokens, like paying $10 to emit a vote and having maybe an average of 3 votes per week, well, is not the most optimal strategy to achieve participation in these votes. So still, the systems of on-chain governance are for already like quite some time live, like 2 years, and more or less everybody is kind of doing the same. you have a token, this token has associated some voting power, and then the smart contract system is kind of based on snapshots of this balance, and with those snapshots you are able to check how much voting influence a holder has. So it doesn't seem that there is so many things to improve. These last 2 years, I will say that the innovations were more on off-chain side, like trying to make optimistic governance and so on. So, well, the big question is what can be improved? Can these systems be really optimizing in a meaningful way? So, yeah, the answer is that we think that that is possible. And especially is possible right now after certain developments that were happening in the, let's say, multi-chain world. So yeah, this is a bit of an illustration of the concept underlying the new Aave Governance V3, and I will explain a bit more in detail, like all these fancy components, let's say. So. First of all, Aave, as I said before, like is a multi-chain protocol. Even if we started on Ethereum, like back in the days, like 2 years ago only, but when networks like Avalanche itself or Polygon started like to be in release and to have production applications, Aave was one of the first protocols that bet on them. And well, the growth of these networks was quite tied to the growth of Aave itself. So it kind of makes sense from a high-level perspective to think, okay, can we do the same that we did like with a liquidity protocol, making it multi-chain? Can we do the same with governance? Can we use the specific characteristics of these networks to like superpower the Aave governance system? So yeah, this is the first idea, and what leads like to the development is, okay, we have Aave governance that is extremely active at the moment with more than 200 governance proposals, all of them on chain. How we can use the underlying network infrastructure especially of non-Ethereum networks to make this system better. Also, another consideration is that, as you can imagine, and I explained before, with this cross-chain governance system that we already have, this was possible because solutions of bridging started to appear, like in the majority of the cases linked to the new networks themselves with canonical bridges. So now this ecosystem of bridges is substantially improving and getting more mature. So there is a lot of hints, or there was a lot of hints that this new system of governance could be created. So things that don't really change much on the new governance V3. Ethereum is still at the core of everything. So basically, it's not so simple because it's not a technical improvement to move, like for example, the assets. So the Aave token and the utility of the Aave token lives mainly on Ethereum. So when you want to vote with those tokens, like you still need to keep Ethereum to make things a bit simpler as the core, because there is where the security lies. Like, so the Aave tokens are there, and at the end of the day, like is debatable, but I think almost everybody agree that in terms of maturity, the Ethereum network is most probably still the most solid of all of them. So it remains kind of the same. Like Ethereum is the settlement layer of the governance, same as the settlement layer of a lot of other technologies like the rollups, but it becomes more oriented to the base functionality of a settlement layer. So it's a layer of validation and mainly access control, and not so much about voting, which is what I will explain after. Voting. So the bottleneck is actually voting, like of the governance, because it's expensive. So for us, it was quite straightforward to say, okay, what if we move the voting to another network, but with full assurances that like the balances are read perfectly from Ethereum, from where they are, and without touching the user experience. So that will mean that with not much bridging of these tokens, because, well, if you need to spend $5 in voting on the current governance and you will need to bridge the tokens on a new solution, probably you will spend the double, at least. That is what we improved, and we are moving voting to a different network, which are environments that are just cheaper to transact for whatever reason this is. So this is quite powerful in terms of modularity, because the new system, well, it has the core on Ethereum, layer of validation again, and then you have like what we call the voting networks. And the voting networks is like a quite abstract idea in the sense that any kind of network, initially EVM, but actually there is no limitation only to EVMs, any kind of network can be a voting chain if it gets approved initially. So yeah, I will explain more the flow after, but yeah, keep in mind this idea of voting network, voting machine, and not really linked to the core and settlement layer. So Ethereum, this is important, is still another network, and Ethereum will be like the fallback network. So meaning that apart from being the settlement layer, we will deploy a voting machine, the so-called voting machine on Ethereum, which in the case of, let's say, an emergency scenario where no network will work properly, well, it will be like the full circle, so like everything will still happen on Ethereum. Obviously, this will not be optimal in terms of cost, but it assures us that there is no external dependency on other networks. Proposal execution is something that also changes a bit. So right now, this is perfectly functional. So you can have execution on Ethereum when you want to do a change on Ethereum or on any other network that is connected with this cross-chain, the current cross-chain governance. But on the new system, we kind of improve and iterate on top of that, because of what I mentioned before, that like the bridging ecosystem has improved really a lot. Before there was only like canonical bridges. Now you have like a lot of third-party entities that are working on bridging problems apart from the canonical. So what we decided to do is we noticed that there was a bit of point of failure on the canonical bridges even, because usually the technology of these bridges is separated from the security of the network itself. So we incorporated in Governance V3 like a new layer, which is for a kind of consensus of multiple bridges to pass messages actually back and forth from these other networks. So this is quite core to the system, because it's not anymore like a unidirectional flow on governance. Like right now, basically you create a proposal on Ethereum, it gets voted on Ethereum, it gets approved on Ethereum, and then or it gets executed on Ethereum, or it gets passed to another network, and that's it. Like the flow finishes there. Now it's not exactly the same as if, for example, you can have a proposal on Ethereum created. It's a bit more complex, but let's say that it's created on Ethereum. Then it gets voted on, let's say, Avalanche. Then the results needs to come back somehow to Ethereum. And then maybe it needs to be executed on, let's say, Polygon. So you have like quite bidirectional flow, and it's more complex. So the architecture needs to adapt itself, like to give solidity to this. So how does this work in practice in terms of steps of like a standard proposal? So yeah, everything starts with the proposer. Well, it's a bit more complex, but let's assume that the proposer is the same entity that creates the payload, which is the executable action that will be enacted. So First of all, the payload now, kind of similar as on governance V2, but in V3 is completely strict. The payload gets created on the target network. So imagine that you want to execute, do an upgrade of the Aave protocol, and you want to upgrade Avalanche, Ethereum, Polygon, all the networks even. So you will create like a payload on each one of those networks with the particular changes that will affect that network. Next step, after you create the payload, by the way, for this creation of the payload, this is completely permissionless. It's just deploy a smart contract and register this smart contract in a permissionless contract. So when you register this payload, you will receive an identifier from this registry smart contract. And this is what actually will get used by the entities that have the so-called proposition power, which is the Aave balance or delegation, to create actually the proposal with the requirements of proposition on the Ethereum core component of governance V3. So yeah, in practice, you could imagine that you are like a developer, you create a payload on Avalanche, like in this diagram. Then you take the identifier of that you get spit out of that payload. You go to Ethereum with your 80,000 Aave tokens, and you can create actually the proposal to start the vote. So yeah, this is the third step, creation of the proposal. Now, there is some delay in the middle, like for preparation of voting power and so on, but just after this delay, things start to get more interesting. So what we do is that we forward the block hash at that point of Ethereum to the voting chain, which in this case is also Avalanche, but it could be any other, like Polygon or any other. So this block hash goes through what we call our cross-chain infrastructure, which is this layer that we created with together with governance V3. And it arrives to the voting machine on the voting network, which kind of marks the start of the vote. So anybody that has Aave tokens on Ethereum now goes to Avalanche and does a transaction on Avalanche. Not touching Ethereum, but only Avalanche. And well, for the people that understand how this world works is, okay, you have balance of Aave tokens on Ethereum, how you can go to Avalanche and vote with that balance without passing a message from Ethereum to Avalanche. So the core of this is storage proofs. Basically, block hash is just a compressed, we could call that a compressed version of all the data on Ethereum that can be proved against. So what that means is that, like, if you take the block hash as at block number X, and you have balance on the smart contract of Aave at that particular moment, you can potentially prove cryptographically that you hold the private key of the wallet that has that balance. And doesn't really matter where you prove that or where you transact that. If the block hash is stored somewhere, you can prove against that. So that was the reason of why we breached the block hash to Avalanche, because once you have the block hash on Avalanche, anybody that has the same wallet that has balance on Ethereum can prove that balance on Avalanche. So this is kind of the same as on governance V2 and as almost any governance out there, technicalities apart. So people just vote on Avalanche in this case by submitting these storage proofs against the block hash. And once like the voting period finishes, let's say 3 days, the results of how many yes votes and no votes need to go back for Ethereum for the validation on the settlement layer. So same as before, but from the other side, we go to the cross-chain infrastructure, and we forward like to the core of Ethereum, of the governance, the voting results, which is just the count of number of yes, number of no. now things are kind of similar as on Governance V2, so there is like a time lock. So let's imagine that the proposal passed because there was enough yes votes. So it gets time locked for 1 day. And after the time lock, let's assume that there is like an update on Ethereum and an update also on Avalanche. So first, the update on Ethereum, which is not included here, but gets executed directly after the time lock. And for the update of Avalanche, there is a bridging of message, again, through our cross-chain infrastructure that arrives to Avalanche. And after also like an extra time lock, and well, this consensus, like in the middle of the cross-chain infrastructure, as always, it gets executed also on Avalanche. So it could be like a listing of an asset, and it will get listed there. So this cross-chain infrastructure is like a bit of like a black box at this moment, like just something where messages go out, but what is inside here? Well, the idea is not really complicated. You have the Aave ecosystem, which is the left side of this diagram, which it can be Ethereum, but it can be any other instance of Aave. And cross-chain infrastructure is just like the channel in the middle, that is a bidirectional communication channel. So it's not that we are building like a bridge, like to pass messages, but what we build is a consensus layer between multiple type of bridges, whenever it makes sense to have multiple bridges, for Aave to keep control of which technologies of bridges are acceptable and which are not. So yeah, I mean, you have bridge 1, bridge 2, bridge 3. It could be canonical bridge of, let's say, Polygon. Another could be layer 0. Another can be bridge X. And on the other side, well, in this case, we have the executor, but basically it can be any kind of component that is permissioned by this for this infrastructure to submit messages to. So yeah, in practice, it's actually like a black box on where we do some extra validations and checks to keep control and to be sure that the bridges that they are that we accept, that Aave accepts, is they have control over them basically. So, which are the at the end of the day, like what other advantages has this new system? So, first of all, again, it's really cheap to vote. But for a bit of context of how cheap is to vote, I commented before, that maybe it's $5 to emit a vote on Aave at the moment. Depending on the execution environment, let's say that 1,000 persons vote, 1,000 wallets. So potentially the $5 could even cover the whole 1,000 votes, like at once. Because as you can imagine, it can be a transaction on Avalanche or on Polygon or even on Avalanche Subnet or any other. And they are extremely cheap execution environments. So like it's yeah, extremely cheap. One of the ideas around this is that the Aave DAO itself could cover the cost of voting for all the users, which will mean that in practice is for free, like to vote via a relayer, and is most probably what we are gonna propose to. Then delegation. I guess some of you are familiar. Delegation is the fact that I have Aave Balance, but I'm not active in governance, so I delegate to somebody else, which are kind of professional, let's say, politicians, and they participate on my behalf. So this new system is fully compatible with delegation. There is basically no change of the dynamics of delegation. It's just that, yeah, the final vote will be just cheaper for this politician or whatever you call it. And the last one is that, yeah, EVM compatible to start with, but the key here is what I explained about the storage proofs. And the storage proof is pure cryptography, so there is no no kind of limitation of that it should be on the EVM. Of course, there is some limitations of the cryptographic algorithms that get used internally, but it is really, really realistic, and we are even working on that, on apply this, deploy voting machines on non-EVM networks. There is like some extra aspects that gets optimized or changed a bit. So the first is a bit technical, but at the moment, if you have Aave token, or even if you have maybe comp or uni tokens, maybe you know that when you transfer those tokens is more expensive than transferring other type of tokens. The reason of this is that for voting purposes, when you have a system that is basically not same as Governance V3, you need to keep historic track of all the balances of all the users. So every time that you transfer tokens, a snapshot gets done saying that at this particular block, this address had this balance. This is quite expensive. But with this new system, we don't need it anymore, because how it works, like all the information is on the block hash that we breach. So we don't need to track per user, because at any point you can generate a proof of the balance that there was at that particular block hash. So yeah, this is a technicality, but transfers of Aave token that right now maybe cost like also $5 in a good day. They should cost less than $1 maybe, with this system, which is a big deal. Then smart contracts, smart contracts cannot sign transactions. So for those of you that are technical, maybe you are wondering, okay, but how you do the signature, how you do the proving of your balance on Avalanche if you are a smart contract on Ethereum with Aave. So for this, we support it still, obviously, because there is a lot of smart contracts participating in governance. But obviously, this needs to go through bridging. It's a combination of bridging plus then proving. But in practice, the user experience for these smart contracts is exactly the same. They will call a smart contract on Ethereum that will vote, and that's it. Then it's a bit easier to expand the set of voting assets. So imagine, now we have Aave, SDK Aave are the main assets, but the community was asking multiple times that we should add as voting asset the Aave that is deposited into the protocol, or other type of Aave like SDK Aave, SDK AVPT, which is another flavor of the safety module Aave. This is not so simple to do at the moment, because the token itself is highly coupled with the governance in aspects like the snapshots of the balances. So if you will try to use any other token, even that is not Aave, that doesn't have snapshots, in practice you cannot use it on a governance like Aave or Uniswap or anything like that. So this way, you don't need anything special on the token. Any kind of ERC20 token can be used to vote. So I don't think that will be the case with other non-Aave assets anytime soon. But with this, allow us to put Aave as voting asset from day 0 on Governance V3, which is quite big in size. And then the last point is that this is purely technical, but pretty important in ecosystems that are like Aave with a lot of contributors, and is that there is way less coupling between the governance and other parts of the ecosystem. So you don't need to think so much anymore that if I change the implementation of the Aave token on the protocol, it could affect the governance. So of course, it could affect the governance, but it's just simpler to reasoning about those changes. And well, yeah. It seems that everything is quite good, completely on-chain governance, cheaper, better. But what are the bad news? There needs to be some disadvantage. Well, there is not really many disadvantages actually. So there is some challenges, but in terms of the base functionality or decentralization and so on, is basically the same, but most probably better for users that right now were just left out participating because it's financially not worth it. These challenges are, well, quite interesting. Yeah. So for new networks, even what I commented is quite abstract, the voting machine. When you have like technology like CK rollups, the way they are implemented, certain cryptography is a bit more complicated. So it's not so possible yet, but we think it will be soon. Voting duration is also a bit more unpredictable because there is more steps. But we are talking about like margin of hours, nothing really major with the times of governance. And well, then how to decide which voting chains are suitable is a topic by itself, not so technical, but as you can imagine, well, there needs to be an analysis of how solid is that network to host an instance of Aave. And yeah, that's it. Nothing else.